Now let's solve this question. Okay, now we need to find the spring constant. Okay, write down the equation F equals to kx. Okay, so in this case, my force is the weight force. Okay, now mass times acceleration. Okay, now my x is the extension, the length, which is 0.025 meters. Okay, put all the value in. Okay, now I have 5 divided by 0.025. It should be, put it in your calculator. It should be 2,200. Yeah, it should be 200, and the unit will be Newton per meter. Okay, not Newton meter, Newton per meter. Okay, we have force divided by meters. Okay, down. Okay, now have a look at this question. Okay, now we have a spring with a spring constant 50 newtons per meter. Okay, stretched by 20 centimeters. Remember, convert them to meters. Okay, how much potential energy is stored in the spring? So remember the spring energy equation. Okay, half kx squared. Put all the value in. Okay, type it into your calculator. You have okay, I think it's 0.4. Yep. Type it in. It's going to be so 0.01 joules. Yes. Yep. Hopefully it well. Well, just do it. Yep. Yeah, should be alright. Should be right. Okay. Okay, now let's go to the next question. Okay, now okay, we have a spring with a spring constant, that's k, and convert it to meters. What is the mass of the object? Okay, now so we need to find the force, the gravitational force first. Okay, so F equals to kx. Okay, put down the value in. Okay, use your calculator. Well, just let me do it by hand. 15, 24. Well, just stay a minute. Let me do it by hand. Okay, now we have 360. Now 360 with a 0, but with 3 decimal place, 3.6 newtons. Okay, now yeah, I think I did. Just check, just let me check. Okay, now I don't want to make a mistake here. 3.6. Yep, that's good. Okay, so 3.6. What's the mass of the object? Okay, so that's the weight force. Okay, now the gravity is mass times the gravity. 3.6 equals to mass times 10. My mass must be 0.336 kilogram. Okay, now down. Now, okay. Again, a question like this. Okay, a force constant K and 40 joule of energy has been done. So that's the spring energy. Okay. Now, what distance has been spring compressed? Use the equation. Put value in. Sorry, I made a mistake. Yeah, give me a second. My x will be square root of half meters. So use your calculator, put down this number. Okay, now let's do this one. Okay, so we have a mass has been compressed by 0.01 meters. Okay. Now the block is released. Leave the contact with point B. Yep. Has a speed of 5 meters per second. Okay, now I think it's blocked. So that's 5 meters per second. So initially 5 meters per second. Okay. Now, what is the spring constant? Okay. Now we know when it's released, all the spring energy are converted to kinetic energy. Okay. So we know the initial speed. That's basically can tell me the kinetic energy, which is all from the spring energy. Half mv squared 2.5 joules. Okay, so that's the spring energy. Okay, and if we look at it, put it in the calculator. 2.5 is half k. Okay, that's a k times the compression. Okay, so if we do that, it will be 5 equals to 0.0001 k. Now, then my K must be 5, 1, 2, 3. Yep, newtons per meter. Okay, the important thing is here, when the spring is released, all its spring energy is converted, is transferred, okay, to actually transformed to kinetic energy. Okay, so yep. Now, okay, let's look at this question. Okay, now we have these people, they're moving from A to B on a roller coaster. Okay, now I need to find, okay, the speed at point B. Okay, so this time we need to use the conservation of momentum, conservation of energy. So the energy before, the total energy before must be the same as total energy after. Okay, total energy after. So have a look at the energy before. Okay, now let's assume the car starts from rest, so there's no kinetic energy. So the total energy will be kinetic energy plus the potential energy. Okay. Now, kinetic energy will be 0. Potential energy is mgh. Okay. So put it in will be times 10 times 20. Okay. Type it in your calculator. I have 20,000 joules. Okay. Have a look at the energy after. At the energy after will be again kinetic energy plus potential energy. Okay. This time the potential energy will be 0 because it is, well, it's on ground level. The height is 0 at point B. So let's have a look at the kinetic energy, half mv square, and it should equal to the total energy before. Then we have an equation. Okay. Solve it. Mass is 1,000, so use a calculator. Square root of 40 is something, okay, in meters per second. Down. Okay. Now have a look at this question. We have a sand mass is 70 kilogram. Okay, let me use a pencil this time. Try to use this one. Yep. Okay. And jumps from a tower in figure 6. The length is L. Okay, the friction, the slide is 300. Okay, now that's the friction there. The total work done in dragging them up will be this. At the top, potential energy was greater by than it on the ground. Okay, now. Okay, at the top, the potential energy this part is this. then okay, the length of the call is 10 meters. Okay, now the boundary call, the pump, the call extended, so the change will be 8 meters. Okay, so the idea is the call, um, sorry, the boundary call act as a spring. Okay, what's the spring constant of the boundary call? Okay, so use this spring constant F equals to kx. Okay, and well, in this question, we're only interested in the spring constant, so uh, we can just forget, we can just ignore all some of the information. Okay, now the force pulling him down will be his gravity force. Okay, so the mass times gravity. Okay, spring constant is unknown. Okay, now the extension of the spring will be 8 meters from 10 to 18. Okay, put it in the calculator. I should have 70 times 10. So 700 divided by 8 newtons per meter. So in the exam, you need to type it in the calculator, find out the value, and write down the unit. Okay, I leave it like this because well, I'm just lazy. I don't want to do this. But in the exam, you need to type it in the calculator and write down the actual value. Now, have a look